Dilation is the enlarging or shrinking of a mathematical element using a specific scale factor. Dilation changes the position and size of a figure, but not the shape. Dilation is one of the 5 major transformations in geometry. All dilations begin with a center point. From the center of dilation, the preimage, the mathematical element before scaling, is enlarged, inverted, or shrunk to form the image. The preimage is the original figure. The image is the new figure after dilation. The center of dilation does not need to be inside the shape. It can also be outside the shape, a vertex of the polygon, or any fixed point in space. Here we still have a square as the preimage, but the center of dilation is the top left vertex, so the dilated images share that same vertex. The scale factor of a dilation is the amount by which all original terms are enlarged or shrunk, usually on a coordinate plane. If you multiply the original coordinates by whole numbers other than 1, you enlarge the preimage. By 1, you produce an image congruent to the preimage. By fractions or decimals, you shrink the preimage. By negative numbers, you produce an image that is the inverse of the preimage. The image is equidistant from the center of dilation but on the opposite side. Here is a trapezoid on a coordinate grid, with the origin 0, 0 as the center of dilation. If we choose a scale factor of 2, every plotted point on the polygon will be multiplied by 2 to create the enlarged image. Take the coordinates of vertex A on the preimage at -2, 1 and multiply times 2. This gives you -4, 2 as the vertex A for the image, the new figure. Vertex D in the preimage at -3, -1 becomes the vertex D at -6, -2 for the image. Can you calculate the coordinates for the new B and C vertices? Point B enlarges to our new point B at 2, 2. Point C enlarges to our new point C at 6, -2. The image has sides twice the length of the preimage trapezoid. Notice that the vertices of our image points share almost the same designation as the preimage vertices, but with the prime indicator. The trapezoid used our origin 0, 0 as the center of dilation. You can move the center to any place on the coordinate plane you wish. Here is a point 4, 5, with the center of dilation at 1, 3. You are asked to plot the image point using a scale factor of 4. The plotted point of our preimage is 3 horizontal units away from the center of dilation, and it is 2 vertical units away. Multiplying these distances times the scale factor 4 means our new point must be 12 horizontal units from the center of dilation, and 8 vertical units from the same center of dilation, at 13, 11. You can check your work by drawing a straight line from the center of dilation through the preimage point. The new image point must lie on that line, and it does. When you do not have the coordinates for the points of a figure on a coordinate grid, you must calculate each line segment of the figure and multiply it times the absolute value of the scale factor. If the scale factor is negative, you will be going in the opposite direction from the point of dilation. But you must take the absolute value to get the actual distance, because physical distances cannot be negative. Suppose you have a preimage of a polygon with a side AB that is 9 centimeters long and a scale factor of -6. The absolute value of -6 is +6, so the image will be larger by a factor of 6. This makes our new side AB 54 centimeters long. This new side will be opposite the center of dilation from the preimage, as will all the other sides of the polygon, since the scale factor was negative.